We can start. Integration versus unit testing. That is the topic of today's lesson. Um, Today we're going to talk about how do we actually distinct unit and integration test one from another. How do we test when there is a dependency to a file or a console? How do we test when there is a dependency from a database? Or how do we test when there's a component as a dependency or multiple components that we ourselves made? When should we prefer integration tests and when should we prefer unit tests? We'll also try to compare the speed of something that was unit tested and something that was integration tested. And we'll talk about how to test private methods and if you should have those private methods that you want to test in the first place. And what is a unit from my point of view? Because to me, a unit can have a dependency, unlike the classical definition says. So let's continue. Integration or unit test? Which should you pick? Classical definition of a unit test says that there's simply a test for a function in isolation. So that means no dependencies, everything is mocked except the class on the test, the function on the test. For integration test, you test class with dependencies as is. In a nutshell, the difference between the two is that unit test is isolated, everything is mocked except the thing on the test. And integration test, you take things as is. However, my definition of an integration test is that it should still be isolated from subsystems. For example, if you're testing something that is database related in integration level, you shouldn't allow other dependencies like email client, like a file, to get in your way for testing a database. If you're testing a file, console shouldn't matter. If you're testing console, file doesn't matter. A subsystem component under test is what I call integration test. And when you're testing something in a subsystem, you can allow dependencies in because you're testing a component. About unit tests, from my understanding, I call unit tests for a unit, and a unit can be or is a feature, isolated feature. No third-party components allowed, but it can have some unmocked classes that are not mocked, and it would still be a unit test as long as it's fast and as long as the other components do not affect it tremendously. Let's see how that works in practice. The first problem that I would like to show is something that I actually wrote for you guys in your homework. In the very first homework, you worked a lot with the console and you had to print different stuff and ask user for input, and I had to test that. And I had to test that in a way that I had to fake the console that you were interacting with. And here's the example of a similar code. Basically, there is a user menu which displays a block of text based on your selection. And for simplicity's sake, I just wrote items and users for different selections. But of course, there could be a lot of more logic, and logic that is not necessarily for displaying something in the console. It could be different things. But that's besides the point. Right now we're focused on console. We have a dependency on console. How do we escape it? How do we test something with console? For example, if we call readline in console when we're running tests, it will expect us to input something. What will the test input? Well, it will simply freeze at that point and will not stop until it timeouts. What should be the solution to this problem? How do we test user menu? And the answer to that is we need to fake the console. And luckily, console supports setting where the input or where the output is going to. And for example, console has a method, static method, set in. So if we say set in for console method, it will set the input reader for us. And string reader, for example, is the most simple one. We can hard code a string in our fake console. We can override how console gets input, and we simply say it gets input from a string. So it's always the same. And now our test becomes very simple. We just say console input is 1, and console input calls the method string reader that is right here. Sorry for the overlay. It calls the string reader that is right there. It sets the value to that string reader. It creates the string reader with string equal to 1. And it says that the console will now return that string reader, and when it gets the value, it will be 1. And thus, when we call readline, it gets that number 1, the string 1, and in console output, which is also faked, which now moves the output to the file, writes the output to the file, it prints items. We run the test, we see it green, it worked. But note how much more knowledge we had to know about the system that we're testing. We had to know how console gets the input so that we could fake it. It wasn't just a matter of using a generic mock. It was a matter of overriding something that works differently normally. If we were to write a unit test for the same, we would need to use dependency inversion principle and hide the console under some interface. And in this case, we use IUserPrompt interface to hide the fact that under the hood we're using a console. Here we use IUserPrompt and it just proxies calls the console. What's the benefit of it? The benefit of it is that the tests become easier, maybe not easier in a way to set them up. Well, for someone new to mocking and unit testing, it might look as difficult, but the same pattern applies to all unit tests. So this is just the same template trivial stuff. Basically, now instead of stubbing out the console, we're just mocking the console itself, not the console itself, but the user prompt, IUserPrompt. And we basically create a stub from mock and saying that our stub read line in here, our stub read line returns input that we pass. So the end result is the same. We again specify what input we set, and then in the end we verify what gets returned. And in this case, we verify if items were printed a single time. And that is the unit test for menu selection. And as you can see, it has three cases. What happens if we select option number 1? What happens if we select option number 2? And what should happen if we select option number 3? And this fully covers menu. What conclusion can we make from this example? The conclusion is integration tests were way more difficult to set up. What I showed was just the tip of an iceberg, because actually the whole flow of how I fake the console hides in console test class. Calling it is quite trivial, I won't argue about that, but it does require extra knowledge that you might not have, and you might need to do extra research to just make simple integration tests. What pattern did we follow when writing a unit test? The exact same one. It was the same thing that we repeated all over and over again, and it was trivial to write a unit test, given we have no hard dependencies on console. Let's look at another problem. This one is a bit more complex, but all of the components, well, all of the components are ours now, we're in control. However, logger and mail client inside depend on something that takes a long time to run. Logger logs to a file. Writing to a file is, in general, any disk-related operation is one of the slower operations in computing. If you can escape writing to a disk, you should. And with tests, we have that option of escaping. But anyways, that's besides the point for now. We have a logger which writes to a file, and we have a mailing client which sends an email to a recipient. And our invoicer works that way, that from amount and recipient, we form an email with how much a person needs to pay. And then we send the email for the mailer client, and the logger just logs if it started and if it ended. What's the essence of this method? We don't care that it logged something, that's just for us. That doesn't need to be tested. It's not the business requirement to log it. The business requirement is that given amount and recipient, you actually deliver the right email to the person, right? That is our business requirement. How does a test look like? If we write integration tests, and again, if we try to somehow test things as is, this time we'll stumble into problems. Here I created a logger which logs to some dummy file. Logger is not a problem. I can log to a dummy file. Here I also created an emailer which sends an email to some dummy email box. Again, that is doable, but that requires setup beyond just coding. That requires some administration on top of just setting up a fixture. Some sandbox email client, email address that you could send emails to. Here we say that sends emails to recipient with the right amount. And what does this mean? Amount doesn't matter. It matters that it sends to the person that we wanted it to send. But when we call the send method, how do we check back that we send to the right person? And the answer is, it's quite hard. We need to, for integration tests, just like, we wrote something, we read something from the console, and then we read the output. But again, everything was from the outside. We just touched and poked around with the poking probe to see what happened to things that we interacted with. That's the essence of integration tests. You can never have direct output. You always have to poke around. Well, you can have direct output, but in this case, we do not have direct output. And when you do not have direct output, it comes not from code. Well, it comes not just from code, but from some other system, other subsystem that you interacted with. And in this case, it's the email. Like, you need to somehow now read the emails of the person you send to in order to see if the right email was sent to them. And that makes it so much more complex than a unit test. In our unit test, we basically put Invoicer email mailing client under a mock and logger under a mock. So we created mocks for those, we mocked them, and what do we do? We just say, so we send invoice and we verify if emailer mock sent expected email. That's quite easy, right? We just set the email that we expect and we verified that it was indeed called. The conclusion here, I had really difficulties in setting up integration tests beyond just coding, as I needed to figure out where do the emails travel, how do I read the email that I got, what do I need to do to send the email altogether, how do I read the email? Those questions haven't been answered even now. And I don't know, to be honest, how to do it. I would probably figure it out, but I don't really have to if I can unit test it. Somebody already tested that the client works. So for stuff that is already tested, you don't need to bother. It's a system that works, and that's a given. Now, what you have, you should isolate the system that works from what you're testing. What are other problems other than being very hard to test? Another problem is that it's super slow. As I said, writing to a file is slow, sending an email may be fast, but it's hard to set up. So slow and hard to set up again, beyond just code. That is another two problems for integration tests. And lastly, we have repository testing. Repositories or data access objects in general communicate with a database. Database is a complex system. So when you are writing a repository, it's obvious that under the hood you have a database. Sometimes instead of a repository, we can have SQL queries. And of course, the SQL queries that we write or the database that we create, or the repository that we create needs to be tested as well, somehow. But the problem here is we have a dependency on database. Do we escape the dependency? First, let's look how you can write integration tests for repository. And there are two ways. You can either use in-memory database. Well, there are three ways. You can either use in-memory database, you can use a local database, or you can use a sandbox database that you either share or have by yourself. The problem with having a fake in-memory database is that obviously you still cannot test SQL queries because they require actual database. How do you get something from a file, for example, that is very hard to set up if you work in memory. However, if you do manage to set up in memory tests for database, they're very fast. They're much, much faster because you're not writing to disk. You're working with memory without any external thing. And another benefit of having tests without external components is that you don't have to dispose them. In this case, I noticed that sometimes it fails, but I couldn't figure out why, so you can just, again, ensure the database gets deleted and dispose it. But the benefit of in-memory tests is that in theory, well, if you stop the testing, what happens to in-memory stuff, it just disappears automatically because that's how memory works. And another kind of testing is using a local database. Again, all I'm showing is examples of how you would do it with Entity Framework, a go-to way of writing code for databases using .NET Core. Here we have Sqlite database tests. Basically, if you inherit this class, you now have your DB context, and DB context is the thing that holds all the database related logic that Entity Framework provides. I'm not talking in detail about Entity Framework here. I'm just showing the techniques that are available to us. Anyways, here we create Sqlite connection, which points to a file name in memory. So this means that just when we again stop the tests and do this connect for connection, it will just drop the database, and when we run a new test, it starts over. And if you want to look more into where I wrote the tests, you can read in the following link. And how do the actual tests look like? Once again, when you do something, you need that external component to help you find something. Therefore, my create called repository create method. But when I see if I created something, I refer to the database context, and I check if after repository creation, after user's repository created a user with a given name, if my context finds a user by that name. And if it finds that user, it should not be null. That means it got created successfully. What about unit tests in this case? In fact, if you were to write a unit test, you would be splitting here basically. It's really not necessary for unit testing a repository because all it does is work with database. And there is nothing that it does by itself complex enough that you should test. Therefore, it's so unnecessary to write unit tests for a repository. Just integration tests are enough, because that is what actually tests if it works. If you just write unit tests and if you trust them 100%, you're shooting yourself to the foot, because they're not a guarantee that code works. And if you don't write any integration tests, absolutely zero, you will not have as much confidence as you could have with your automated tests. Again, another link, if you want to read about all those three options, here's the link below. But to summarize this point, when you have infrastructural components that depend on some third-party stuff, don't be afraid to write integration tests for that. So often, third-party components do not come with perfect design or wasn't at all intended to be mocked or replaced with something. And enforcing the replacement or escaping from it can sometimes be unnecessary. You should escape dependencies at subsystem level, but not at system level when different subsystems interact. But inside a single subsystem, when you're testing insides of a subsystem, it's fine to depend on stuff as is, as long as it is the essence of that system. Now that we saw how to test with unit tests and with integration tests, why should we prefer unit tests? And the number one thing is that they are very fast. They are hundreds of times faster than integration tests. They simplify the testing process. They don't require you to set up different sandboxes. And if something fails, the problem is localized. You know exactly which function failed without having the need of going through the related components. The benefits of integration tests are that they are powerful. They give us higher confidence that our code works. And for components testing, they're great. However, the downsides are obvious as well. As we saw, they're difficult to set up. They're broad in scope. They might require special sandboxes, and they're slow. They're just very slow. And therefore, when you're writing integration tests, you should think, how can you isolate them from unit tests? Because if you have millions of tests in a big system, let's say, and each test takes half a millisecond for a unit, and let's say 5 seconds for integration tests, if you have million tests that are all integration, that each takes 5 seconds, now you have tests that basically don't stop running. Of course, I'm exaggerating, but you want to minimize the amount of time you wait for the results of tests. You don't just run tests and go for coffee. You write a function, run all tests to see if it still works, wait a few seconds, get the results. Writing tests is a problem of optimization because you don't want to wait. Now let's try to discuss the problem with purist unit testing. Imagine you have a bunch of private methods and one public method which calls those private methods. Those private methods are not simple. They have complex logic. And sometimes it feels out of place. Sometimes it is in the right place. But we want to test it. We have like a little town of functions that we want to test, but how do we test it? There are 3 solutions that I can think of. Solution number 1 for testing private methods is making those methods internal instead of private, and using internals visible to attribute, which allows test project to access those functions. However, there is a problem. You couple the test with your project, and you don't want that. Source code shouldn't be coupled. Another problem with that is that you have a different access modifier than you initially wanted, and the attribute itself. So you pollute your source code with something that shouldn't really affect it. Testing code should not affect your source code. If it's untestable, it's a problem of design and needs to be redesigned. Attributes like internals visible to are not a solution for poor design. Therefore, solution 1 is not really a viable solution. Solution number 2, use reflection, is as bad because it makes test logic very complex and it makes it really easy to break. If our function name changes or access modifier changes, the test breaks. Solution number 3, instead of testing private methods, split those private methods into a private component and make those private methods public. From one class that refers to that private component, everything is still private. But now from external component, you can still test those public methods. We have a component that is referred from the stuff where we split it from. In purest approach, that component shouldn't be hard-coded. It should be injected and tested. And when we test the class that holds that component, it should have that component mocked when unit testing. And therefore, we test that class in isolation. That is the purest approach. If we start splitting everything bit by bit and take pieces apart and put everything under the interface when we don't have to, when it's not needed, and it's not needed when we just want to test it, we should reconsider. However, if splitting it is just because it violated single responsibility principle, then please and do so and put the interface and all the needed things because it improves the design. However, there's another approach, the pragmatic approach. And in this case, it's fine. If you have a private function, a bunch of private functions, which you just want to test, and they are in the right place, they just need to be tested. Well, you can simply split it and hard code the dependency. And in this case, hard coding is fine. In all other cases, it's not. It's like 1%. I'm talking about 1% of cases where hard coding a dependency is fine. That's literally one of the few cases. Therefore, if it's just for test, hard code it. It's fine. And that's it that I wanted to talk about today. About the difference between unit and integration tests. Prefer to write unit tests in mostly all cases because they're faster and easier to write. But please do write integration tests when you're working for a specific system or a specific kind of infrastructure. For example, database. For example, I don't know, mailing. But if you are writing something like your own mailing client, then that becomes your own thing, your own component that needs to be tested. In any case, code should be tested. Integration or unit test, it doesn't matter as much as long as it is tested. And when talking about what is which test, all you have to understand that when you think about unit tests, you think about fast tests that kind of have isolated components, but doesn't really have to. However, if you talk about integration tests, everything is cut off in a system subsystem level, but you don't mock anything. You just test it as is. But they're slow. They're slow and often indirect. Like you cannot verify if something was done through a mock. Keep in mind that if infrastructure layers overlap, and in your database layer, let's say you also locked a file, you should rip it out, the file logic, and mock it when testing the database layer. Why? Because it doesn't belong to the logic. You're not testing logging, it was tested elsewhere. If it's a part of logic, you can verify if logging was done. But that is not the essence of testing that subsystem. As I mentioned, do not take a different subsystem when you're testing a certain subsystem. Keep it in isolation. And when talking about integration tests, isolate other subsystems from the one that you're testing. When talking about unit tests, isolate other features from the one that you're testing. That's all I wanted to say. Now, do you have any questions about the lesson? And if you do not have any questions, I would appreciate if you could say one thing that you think understood very well in this lesson, and one thing that you would like to understand a bit better, or a question, maybe. Yeah, all right, guys. There is no homework yet for this lesson and the previous lesson. However, for the previous lesson, I'm going to redo it. As I said, I quite messed up while doing it. Therefore, I'll try to redo the TDD lesson, and I'll focus on problem solving aspect and the efficient approach, because the last time when I showed TDD with problem solving, it was anything but efficient. So I'll try to show how tests can actually speed up your problem solving. Um, yeah. That's it. Thank you very much for watching, and see you tomorrow.